In this video, what we're going to work on is solving rational equations. Now, what rational means is fractions. So we're going to solve problems that have fractional expressions separated by an equal sign. Now, before we do this, let's start with something that we're more familiar with. Now, just notice that the new thing in these problems is that we have an x that is in the denominator, whereas previously when we try to solve linear equations like this one right here, we had fractions, but there were no variables in the denominator. Now, the way I'm going to attack this problem is a little bit different than how we usually do this in class. The first thing I want to do is I want to find the lowest common denominator. Now, the way I'm going to find a lowest common denominator in this problem is I'm going to factor the denominator. Now, I know a lot of you are wondering, well, why don't you just use 10? Because I can see that it's 10. And the reason why is that I want to show you a pattern that we're going to use for the new problems we're going to solve in this section. So let's factor the denominator. So I have x over 2 is equal to 21 over 2 times 5 minus x over 5. And notice that we're only factoring the numbers in the denominator. Now, in order to find a lowest common denominator, what I want to do next is I want to add missing factors to the denominator. Okay, so we have this problem. And in order for me to have a common denominator, I'm missing a 5 over here in the denominator, and I'm missing a 2 over here in the denominator. Now, my denominator has a 2 and 5 for each one of these terms. Now, once I have this situation where I have a common denominator, what I'll do is I'll multiply both sides by the lowest common denominator. In this case, it's 10. So I'll multiply 10 to this side. And when we distribute it, times 5x over 10, 10 times 21 over 10 minus 10 times 2x over 10. We can now cross out the lowest common denominator with the denominator. Okay. Now, in the future, if we sort of go back to where we originally came from, once we have the lowest common denominator, we can do all these steps, or visually, we can just cross out the bottom, and you'll see that the numerators give us what this eventually turns into. Okay, so I'm crossing out the bottom just so I don't have to write all these extra steps. Now, once we have this, we can solve this. We get x is equal to 3. So this is sort of a different way of solving a linear equation that we knew before. And the key thing here is find the lowest common denominator by factoring the denominator, add the missing factors so that each of the denominators have exactly the same factors, and then we cross it out and we just solve whatever's left in the numerators. Okay. Now, this is different from our next series of problems because there is no x in the denominator. So first, let's do this problem on the left, and then we'll contrast it from the problem on the right. Now, the first thing I want to do is what I did before, is factor the denominator, because I want to find the lowest common denominator. So the first thing I want to do is find a lowest common denominator, and I'm going to do that by factoring the denominator. Okay. So in this case, we get 1 over x minus 4 minus, the only term we can factor is this one right here. Okay. Now, when we get to this point, we want to find our restrictions. If we think of, if we look at both of these expressions and we say, what is the domain on this side and what is the domain on this side? The domain is all numbers that, that do not make the denominator 0. So the numbers that make the denominator 0 in this case is 4 and negative 4. If I put a 4 in here, I'll get a 0 in the denominator, which is undefined. If I put a negative 4 in here, I'll get a 0 in the denominator, and I'll get undefined. And those two numbers will also make these two numbers undefined. So what this restriction means is that our answer can be any value except for these two values. So if our answer happens to match one of these two values, we have to cross it out. Okay, now, going back to our original problem, let's look at this and say, okay, let's find our common denominator. Now, when I compare this to this, what this is missing, what this term is missing, is a x plus 4. This one is not missing anything. So when we copy it exactly, this denominator looks like that denominator. And what this term is missing is an x minus 4. Okay. Now, we can see in the problem before that when we have a common denominator, we can just cross out the denominator. So in this case, we will cross out the denominator. And now what I'm solving is just whatever's in the numerator. And then let's distribute that. And now we just have a linear equation that we have to solve. Okay. Let me get rid of this 2x. Get rid of this 8. Let's divide both sides by 4. We get x is equal to 3. Now, before we can officially say x equal to 3 is my answer, I have to check it with my restrictions. If I plug in 3 into the denominators, does it make any of these denominators equal to 0? And the answer is no. The only two numbers that make the denominator 0 is 4 and negative 4. So after we check the restrictions, we see that these numbers do not match this number, so that's my answer. So let's try this problem now. Okay. So we're going to do all the same loops. We're going to first factor the denominator. And then we're going to want to make these denominators look exactly the same. So what I'm missing on this term, so it looks like that denominator is a x plus 1. What I'm missing on this term is a x minus 1. And this last term is not missing anything. Now at this point, once we find the lowest common denominator, this is probably the best place to look for the restrictions. So when I look at each denominator, what number can I put in here and have this whole thing turn into 0? And the answer would be 1. Over here, if I plug in a negative 1, that'll turn into 0. And since we have lowest common denominator, that would be the same here and here. They have the same restrictions. Okay. So once we found out our restrictions and we have a lowest common denominator, we can just cross out the denominator. So all we're doing now is solving the numerator. So over here I distributed the 1, I distributed the 1, and then just copied down the 2. Now when we solve this problem, and let's divide both sides by 2. Okay. I have to check the restriction. Does this number match one of these numbers? And the answer is yes. The reason why it matches it is that if I put x equal 1 into here, let's just sort of show you. So if I have 1 over x minus 1 plus 1 over x plus 1 equal 2 over x squared minus 1. If I put a 1 in here, I end up getting 1 over 0 plus 1/2 is equal to 2 over 0. Anytime you have a 0 in the denominator in any kind of problem you're trying to solve, this automatically is a bad solution. We call this an extraneous solution. It's a solution that pops up when we're doing our computation. That's a false value. So this 1 over 0 is equal to undefined, which means that x equal 1 is a bad answer. So what your answer should be is undefined. Okay, so let's review. When you have a rational equation, what you want to do is factor the denominators, add the missing factors so you have a common denominator, and then cross out the common denominator. Then what you'll do is you'll solve whatever's left in the numerators. Once you find out what your answer is, compare it to the restrictions. If it matches the restrictions, cross it out, it's a bad answer. If your answer does not match the restrictions, then that is a valid answer. So just so you know, when you're doing your computation for your exam, you won't be doing this part. This is just an example of why this is a bad answer. Okay. Now, let's do one more problem. So if I decide to sort of make the problem a little bit harder, I can give you something like this. Let's follow all our rules. The first thing we'll do is we'll try to find the lowest common denominator. And the way we'll find the lowest common denominator is that we'll factor. Okay. And using whatever factoring technique you like, in my class, we would use X factoring, but every class uses a slightly different version. Now we want to find the lowest common denominator. So the question is, what am I missing here? That's here and here, and the answer would be x plus 3. And then the next question is, what am I missing here? That's here and here, and the answer is x minus 2. And this denominator is not missing anything. Now, I have a common denominator, so I can cross out my denominators. And now we're just going to solve whatever is in the numerators. So let's distribute this part. Okay. And then let's combine like terms. Oh, I'm sorry. Okay. Now, this problem is different from the previous page's problem is because we have a quadratic. We have something that's degree 2 here. We don't have a linear equation. So if we look at our previous problem, after we cross out the denominator, nothing here has a square. Over here, nothing here has a square. So when we do that, we combine like terms and we solve for x just like we're always happy to solve for x. Now the problem over here is that we have a quadratic here. That's degree 2, right? We have to, so the only way to solve something that's a quadratic is to make one side equal to 0 and then to factor. So because that's a quadratic, we have to make one side equal to 0. So in this case, let's get rid of this stuff. Let's bring it to the left side. And now the question is, how do I solve this? So use whatever factoring technique you like. In my class, it would be X factoring, but again, every class has their own sort of flavor depending on what your teacher likes. So when we factor this, this turns into x plus 3. X plus 1 is equal to 0. So our answer will be x plus 3, and then, is equal to 0, x is equal to negative 3, and x plus 1 is equal to 0, and x is equal to negative 1. Now, before we can say this is our answer, let's go back to when we had the lowest common denominator and find our restrictions. What number makes this binomial 0? And the answer is 2. What number would make this binomial 0? And the answer is x is equal to negative 3. So any answer is correct as long as it is not 2 or negative 3. And when we check that with what we computed, we can see that this right here is a bad answer. This is our only answer. Now, when you solve a rational equation that turns into a quadratic equation, right, something with a square, you can have two answers. You can have one answer, like this problem. If both of these numbers matched the restrictions, we would cross everything out, and we would say that the answer is undefined. In this case, we have one answer, which is negative 1. All right, thank you for watching.